Welcome to a new video by Wiskunne English. In this video we're going to talk about the determinant of a matrix. Let's start with a 2x2 matrix. Suppose we have A, B, C, D. Now we're trying to calculate the determinant of this matrix. So if you want to calculate the determinant, you use this notation. There's a formula for a 2x2 matrix. So you multiply A with D and then minus B with C. So A multiplied with D minus B multiplied with C. An example: 1, 2, 4, 5. 5 minus 8, because 1 multiplied with 5 is 5. 4 multiplied with 2 is 8. 5 minus 8 is minus 3. So this is determinant minus 3. Next we're going to talk about a 3x3 matrix, and then we're going to talk about the properties of a determinant. So in the example of a 3x3 matrix, we're not going to use any property of the determinant. We're just going to calculate it without simplifying things. Suppose we have this matrix, so 3x3, and we're going to calculate the determinant. I know normally you use row operations or you simplify things, but in these examples we're not going to use it. So how do we do that? We pick a row or a column. It doesn't matter here. We take, for instance, the first column. When does it matter? For instance, when you have two zeros in a row or a column, it's best to take that row or column, because 0 multiplied with something is 0. So it's easier. But here there are no zeros. So first row, we start with the first element. So the first element is 1, and it has row number 1 and column number 1. That's important because we start with minus 1 to the power of row number plus column number multiplied with this number, so multiplied with 1, and then we remove the row number and the column number. So row number is 1, column number is 1, so we multiply with the determinants of this. So we multiply with 2, 3, 5, 6. I will rewrite the determinant to make it more visible. For the second element, so the second element has row number 1, column number 2. So we're going to remove row 1 and column 2. So we have plus minus 1 to the power of 1 plus 2, row number plus column number, multiplied with 2, the number that's here, multiplied with the determinant of 1, 3, 4, 6. Okay? Then I will rewrite the determinant to make it more visible. So we have 1, 2, 3, 1, 2, 3, 4, 5, 6. So last element is this one, row number 1, column number 3. So we get plus minus 1 to the power of 1 plus 3, multiplied with 3, multiplied with, we remove row 1, column 3, so multiplied with the determinant of 1, 2, 4, 5. Now, we can calculate some things. Minus 1 to the power of 2 is just 1, so I remove this. Minus 1 to the power of 3 is minus 1, so instead of the plus I will write minus. And minus 1 to the power of 4 is still plus 1. So it becomes plus. So we have 1. Determinant of 2, 3, 5, 6 is a 2x2. So a 2x2, remember, determinant of a 2x2. So the determinant of a 2x2 is AD minus BC. So we get 2 multiplied with 6 is 12, minus 15 is minus 3. Then 1 multiplied with 6 is 6, minus 12 is minus 6, minus 6 multiplied with minus 2 is plus 12. And then we have 5 minus 4 multiplied with 2 is 5 minus 8 is minus 3. 3 multiplied with minus 3 is minus 9. So we have 0. It's not surprising, but some of you may already have seen it, that the determinant of this matrix is 0. So how do you see that before calculating anything? Now, we had the matrix 1, 2, 3, 1, 2, 3, 4, 5, 6. When you have two rows or columns that are the same, then the determinant of the matrix is 0. And here you see row 1 and row 2 have the same number. So 1, 2, 3, 1, 2, 3. So row 1 and row 2 are equal, so the determinant is equal to 0. Or you can say, I can use row operations, so I can write row 1 is equal to row 1 minus row 2. So you can say row 1 is equal to row 1 minus a multiple with row 2. So you can also write row 1 minus 4 times row 2, for instance. But here it's better to write just minus row 2. What will happen? You get 1 minus 1 is 0, 2 minus 2 is 0, 3 minus 3 is 0. So you get a 0 row. And if you have a 0 row, you also have determinant 0. So there are two ways to see it. If you have two equal rows or two equal columns, then you have determinant 0. If you have a 0 row, you also have determinant 0. So we already said you can do row operations. So you can say row 1 is equal to row 1 minus a multiple with another row. And you can use column operations. So you also can say column 3 is equal to column 3 minus column 2, for instance. So that is what you can do. Well, there are other things that you can do. You can take, for instance, you can switch, for instance, some rows. So you can say, if I take an example of a 2 by 2, we have 2, 3, 4, 5. So if we calculate this determinant, we get 2 multiplied with 5 is 10, 10 minus 12 is minus 2. Suppose I switch row 1 and row 2. So we have the determinant of 4, 5, 2, 3. And then we have 12 minus 10 is 2. Oh, this was minus 2. So minus 2, and here we have 2. So what do you see? If you switch rows, yeah, then the sign will change. So here you have minus 2, here you have plus 2. If you had plus 2, it becomes minus 2. So if you switch rows or columns, yeah, it will change. If I switch these two columns, 5, 3, 4, 2, 10 minus 12, and you get minus 2. So I switched from this matrix the two columns, so I get plus becomes minus. So switching rows of columns just changes the sign. Then next, suppose you see that you need to calculate this matrix, and you say 120, 240 is a lot of calculations. But what you do, these two are multiples of 120. So you can put 120 in front of it. So you get 120 times determinant of 1, 2, 15, 30. So now you see 1 multiplied with 30 minus 30 is 0. 120 times 0 is still 0. But it can be that it's not, for instance, if here it is 45. Here it's 45. Then you have 45 minus 30 is 15. So you get 120 times 15. So it's much more easy to do 120 times 15 than to do 120 times 45 minus 15 times 240. So here you get 120 times multiplied with 15. If you want to know it, 10 times 120 is 1200 plus 600 is 1800. Okay? So if you can take a multiple outside of a row or column, you just put it in front of the determinant. Last one, if you have the transpose of a matrix, so if the rows becomes the columns and the columns become the rows, So this matrix becomes 2, 3, 4, 5, nothing changes. 2 multiplied with 5 is 10, minus 12 is minus 2. So the first row became the first column, the second row became the second column, and you see nothing changes. So the determinant of A, the transpose of a matrix, is equal to the determinant of A. So this was the video about the determinant of a matrix. In the next video we're going to talk about the rank of a matrix. And then after the rank of a matrix, we're going to use the rank for system of equations. So the next video is about the rank, and after that video it's about system of equations. I hope you enjoyed this video. Please drop a like and subscribe to the channel.